In this video, we're going to use what we learned in the last one about constants to make a little row of blocks. Now you might be wondering, that doesn't look like the names for any of these programs. Weirdly, the RowOfBlocks program is hiding a little bit down, so if you scroll down, you might actually see it on your screen. I'm going to double click and open this. Now, right off the bat, you're going to see something that looks a little similar to the last program that we saw, but different than any of the others, which is that I actually have some code to start out. And specifically, this code that I have is a bunch of constants. Now, let me actually explain what these constants mean in terms of what we're trying to make. So, unsurprisingly, the RowOfBlocks program is going to make a number of little squares that just sit in a row together. So let's look at this picture here, and let me explain in terms of this picture what each of these constants mean. Start X and start Y are the top left corner of the very first block, or the one all the way on the left. Number of blocks, or num blocks, is pretty self-explanatory. There's going to be 20 blocks all the way across. I didn't actually draw 20 blocks on here, but when we write our program, there will be 20. Block size is both the width and the height of each of the blocks, since they are squares. And this gap variable actually represents the space in between each block. So we're going to use all of these constants to be able to build our row of blocks. To start, how many blocks am I making? If you said 20 or if you said num blocks, that's correct. That's exactly how many I'm going to be making. Aren't I doing something over and over again in this program, which is making a block? And when I'm doing something over and over again, we know that we have both a for loop and a while loop that can kind of repeat code. Do I know exactly how many blocks I'm going to be making? I do. I have a number of times that I know I need to repeat. So what am I going to use here? I'm going to use a for loop. Let's start with for int I equals 0. I is less than. I could put 20 here, but that's not the point of constants. If I literally put the number 20 here, then if I wanted to change the number of blocks, I'd have to change it in the for loop. Let's use the constant num blocks, I++. And I know we haven't typed that many for loops yet. I promise later on you'll learn kind of what all of these things mean within the for loop, but for now we're just going to get in the habit of typing it. Now, what am I doing over and over again num blocks times? I'm making a new block. So let's say grect block equals new grect. And this is where this starts to get a little bit tricky, because the x and y coordinates of the blocks aren't actually always the same. Actually, let's think about what I just said for a second. One of those two things is changing, and one of those two things is going to be the same for every block. If we look at the blocks, remember the x, y for a grect is the top left corner. Do the blocks have the same x coordinate or the same y coordinate? Looks like they all have the same y coordinate since they're all at the same level with each other. They're all at the same height. So let's pause on the x coordinate for a second. I'm going to put a little placeholder in there. For the y coordinate, it seems like they're all going to be just at the starting y. So I'm going to do start y. And the width and the height are pretty straightforward. It's just block size by block size. Now let's think about this x coordinate, because this is where things start to get a little tricky. I know that the x coordinate of the very first block is going to be start x. Now the problem with this is that if I just do this and then I do add block, they're all at the same location, right? Start x, start y, block size, they're not actually all in a row. What do we know about the second block? The first block starts at start x. What's the x coordinate of the second block? Isn't it actually start x plus 1 block size plus 1 gap? And what about the third block? Isn't it start x plus 2 block sizes plus 2 gaps? So you see how as my for loop keeps going, as I get more and more blocks down, they're actually getting pushed further and further to the right by the same amount every single time. Now, there's something really important that I have to teach you here about for loops, which is that the way that a for loop works is that there's this variable called I that keeps track of how far we are in the for loop. When the for loop starts, I always starts at 0. But as we keep looping, as we keep repeating whatever action we're taking, I increases. That's what keeps track of how many times we've repeated. We can actually use this I to represent the idea of which block am I on. And we can do this mathematically. I'm going to type this and I'm going to let it sink in for a second and then I'm going to talk about it. I'm going to do plus I times block size plus gap. And let me put the rest of this on the next line just to space it out a little bit. All right, what have I done here? Well, by the same logic that we were thinking about before, what's the x coordinate of the first block? We know that it should just be start x. When I start my for loop, what is I? It's 0, so all of this will go away. What's the x coordinate of the second block, or block number 1? It's going to be start x plus an extra block size plus a gap. On the second time my for loop goes, I will be 1, so it will be start x plus block size plus gap. Do you see how as I increases, every single time I'm adding on an extra block size plus gap? That's going to make it so that our pattern actually works out exactly the way that we want it to. The last thing, just to make our blocks look a little better, I think this looks a little nicer, let's do block dot set filled to true. You can set a color if you particularly want to, but I'm just going to leave it at this. Let's compile, and I'm going to go ahead and run this row of blocks program. And there we go. There's our row of blocks. And remember, just to remind you the great thing about constants, let's say I wanted to change this to make the block size be 10. I could easily just change the number up there, compile, and run this again. And now look, I have little baby blocks. Let's say I wanted to make the number of blocks now be 40. Let's compile, rerun this, and now I have a bunch of little baby blocks. I could also make the gap bigger so that they're more spaced out. And again, every single time I'm doing one of these things, they're kind of off the screen now. If I expand it, we'll be able to see all of them. Every single time I do this, I make this change, it's changing for every single block because I was able to use these constants in the math that I was doing. If I had had just the numbers in here, I would have had to actually change it in my code. And again, that's the power of a constant. So what do I want you to take away from this? Again, we're just practicing this idea of using constants in our programs. And the other big idea here was this idea of the I in the for loop, kind of counting how many times we've repeated and being able to use that in interesting ways.